Welcome back, dear children. Now we will move to our next topic, power. Okay. So we have already discussed about work and energy, and the next thing is power. Do you know what is power? Power means how fast or slow we are doing a work. Okay. So if power is more, means we will complete a work within a short period of time. If the power is less, means the work will be completed, but it will take more time to complete that. Isn't it? That is what power means. Okay. So power is the rate of doing work. Okay. What is power? Power means the rate of doing work. That is, we are doing a work, but it will be checked how much time is needed to do that work. Power is represented by the letter P. Power is rate of doing work. That means work by time. If the word rate is there, that means you have to divide it with the time. Okay. Dividing by time stands for rate. So power is equal to rate of doing work, means it is work by time. Power says that how fast or slow a work is completed. That is power. Okay. So you are doing a work. If only small period of time is taken, then you can say that the power will be more. Okay. If the power is more, if you are using a machine, if the power of the machine is more, means you can complete the work in a small interval of time. If the power of the machine is less, means more time will be needed. Okay. So is it clear what is power? Power means it is the rate of doing work. That is work by time. Now from here, what will be the equation? Sorry, unit for work. What will be the unit for power? SI unit for work is joule. Time is coming in the denominator, so I should put a bar sign. SI unit for time is second. So joule per second is the SI unit of power. And this joule per second is represented as watt. Okay. Watt is the name of a scientist. That is why here I have used capital W, since it is the symbol. And when we are writing the full name, we have to write it in small letter. Okay. So SI unit of work is joule and SI unit of time is second. That means joule per second is the SI unit for power. And this joule per second is known as watt, which is named after the scientist Watt. Okay. So since I have written the symbol capital letter, full name means it should be in small letter. Now, already I told you here you have to study the definition for the units, isn't it? Now, how can you define 1 watt? When will be the power be equal to 1 watt? If I want to get power as 1 watt, work done should be 1 joule and time should be 1 second, isn't it? So, 1 watt will be the power of a machine if 1 joule of work is done in 1 second. If 1 joule of work is done in 1 second, then the power of that machine will be, or the power required will be 1 watt. Okay. So please study the definition of the unit also. Power is work by time or rate of doing work. Watt is the SI unit or watt or joule per second. 1 watt is the power required or consumed when 1 joule of work is done in 1 second. Okay. So is it clear about power? Power and its unit. Now, sometimes it will be given in this watt can be. Watt means it is the SI unit. Power may be in higher or smaller units. If it is given as kW, that is kilowatt. Kilo means it will be always 10 raised to 3. Okay. Into 1000 you have to do. When you are doing the numericals, always it should be in the SI system. So for higher values, if the power is so high, it will be given in kilowatt. Kilo means, if kilo is coming as the prefix, it means multiplying with 1000. Sometimes it will be capital M. Capital M stands for mega. Mega means it will be 10 to the power 6. So you have to multiply with 10 to the power 6. Then it becomes 10 megawatt. Okay. Mega means 10 raised to 6. Then if it is smaller, 10 raised to minus 3. If 10 raised to minus 3 is there, that is milliwatt. Okay. So these are the different bigger as well as smaller units. Last year or before in 6th standard or something, you have learned about the different units, isn't it? So you have the smaller units as well as bigger units. Bigger means usually in physics they will give in kilo or mega. Kilo means 10 raised to 3 and mega means 10 raised to 6. Then smaller means in milli. Milli or micro. Milli means 10 raised to minus 3 and micro means 10 raised to minus 6. Those are the smaller units of power. Okay. So I hope it is clear for you about power. Then next comes about the differences between energy and power. So that is also important. We have discussed about energy and work, energy and power. Work and energy are having same dimensions, but there are differences between energy and power. Okay, so we'll check the differences between energy and power. What is energy? The ability or capacity to do work. Ability to do work. First difference, you can write the definition itself. Okay, definition of power as well as energy can be considered as the first difference between the two. So energy means it is the ability or capacity to do work, whereas power is the rate of doing work. That will be the first difference. Now second one, you can write about the unit. In the case of energy, SI unit is joule, but in the case of power, SI unit is watt. Okay, usually only two or three differences will be asked for the exam. So be thorough with two or three examples, two or three differences. So there first difference can be written as the definition. Second one about the unit. Now third one, when you are considering energy, in the equation to calculate work or energy, we don't have time. That means energy is independent of time. Whereas in the equation for power, we have time. That means power depends on time. That is the third difference. Energy is independent of time. Power depends on time. Now the next one. Greater the amount of energy, more work can be done. Okay, more energy is there means more work can be done. Then if the work is done at a faster rate, then the power will be more. Okay, we need more power to do some work do a work faster. If you want to do a work faster, more power is needed. Then if more energy is there, more work can be done. Now the last difference is to do 10 joules of work and energy of 10 joule is consumed, whereas to do 10 joule of work in 1 second, power of 10 watt is required. So they have taken it from the definition. Okay, so no need to go deep into that. Just consider 2 or 3 differences between energy and power. Clear? So with this we completed the chapter. Now we will be moving to the homework questions. Please take page number 62. Page number 62, answer in brief question number 3 and 6. So that I think you can write in the textbook itself. Question number 3, name the physical quantity whose unit is watt. So which is the physical quantity with unit watt? It is power, isn't it? Power is the physical quantity with unit watt. Now question number 6. What is the power of an engine which is working at the rate of 1 joule per second? 1 joule of work is done in 1 second means what is the power? It will be equal to 1 watt, isn't it? Power is equal to 1 watt if 1 joule of work is done in 1 second. So you can write it there as 1 watt. Question number 3 and 6 in answer in brief. No need to copy into your notebook. You can write the answer in the textbook itself. Question number 3. Name the physical quantity whose unit is watt. Answer is power. Then what is the power of an engine which is working at the rate of 1 joule per second? answer is 1 watt. Okay, or you can write power is equal to 1 joule by 1 second, which is equal to 1 watt. That is the answer. Don't copy it again into the notebook. Now, question number 7. Question number 7 you have to write as homework. Differentiate between energy and power. 5 differences are given. Just write any 2 differences. 2 or 3 you can write. Okay. Write any 3 differences between energy and power. So you can draw the box and you can write that. What is given in the textbook. Clear. Draw the box. Differences means it is better to draw the box and write that. Now, question number 8. A marathon runner does not feel exhausted as much as a sprinter does. Explain. So, this is another question for you to think. We'll discuss it during the Google Meet. By that time, just think and collect the answer. No need to just check in your in the Google and all to get the answer. Just think and get the answer. Okay. Then we will write it during the Google Meet in your notebook. Question number 8. So, for you, I have given only one question to be written in the notebook from this part. That is question number 7. Differentiate between energy and power. Okay. So, in total 3 question answers. Now, we have one question answer as well as one problem to solve. That we will do now. Okay. So, take the notebook. We will do question number 4 given in answer in brief. It's a very, very important question. Okay. Question number 4 given under the heading answer in brief. Please copy the question. After that you can write the answer. If the speed of a body is half, how will its kinetic energy change? So this is the question. What happens to the kinetic energy if the speed is half? For such questions, these are questions which are there for comparison. Okay. So for such questions, what you have to do is, first you should write the standard equation. Then you have to write the equation with the changes given in the question. Then divide these 2 equations. Okay. I'll repeat. For comparison type questions, that is where the numerical values are not given, first write the standard equation, then write the equation with the changes given in the question and divide both. Okay. So here, first, in the first case, let me take it as K1. Kinetic energy K1 is equal to half m v square. Okay. So that is the standard equation for kinetic energy. I have taken it as K1. Now, what is given in the question? If the speed of the body is half, same body, so there will be change in the kinetic energy. So I have taken the new kinetic energy as K2. K2 is equal to half into, there is no change in the mass since we are considering the same body. Okay. Half into m into, here the speed of the body is half. That means v becomes v by 2. Okay. So this is how you have to do such questions. First you should write the standard equation. So K1, I made it as K1. K1 is equal to half mv square. Second equation should be written with the changes given in the question. Here it is given that the speed of the body is half. Speed is half means velocity becomes v by 2. Since whole square is there, I have given. Now the next thing is divide these 2 equations. K1 by K2 is equal to half into m into v square. This dot stands for multiplication. Half into m into, how much is v by 2 the whole square? It will be v square by 4. Okay. Half and half gets cancelled. M and m gets cancelled. V square and v square gets cancelled. And what are we getting here? K1 by K2 is equal to 1 by 1 by 4. Okay. How much is 1 by 1 by 4? reciprocal of a fraction, isn't it? 1 by 1 by 4 means it will be equal to 4 by 1 or 4. Okay, 4 by 1 or 4 you are getting there. So K1 by K2 is equal to 4. So we are asked to calculate the new kinetic energy. New kinetic energy is K2. K2 will go there. Okay, K2 will go there and 4 will come down. So K2 is equal to K1 by 4. That means if the speed is half, kinetic energy becomes 1/4 of the original kinetic energy. Okay, so what happens if the speed is half? K2 equal to K1 by 4. That means if the speed is half, kinetic energy becomes 1/4. Okay, so once again, first I have written with the standard equation, then I have written with the new one, that is speed is half, then divide both. Here half m and v square gets cancelled, and here you are getting 1 by 1 by 4. 1 by 1 by 4 is 4. So K1 by K2 is equal to 4. Then what happens? I have taken, this is similar to cross multiplication. Should I do it again and show? Not sure whether you know about these changes. K1 by K2 is equal to 4 by 1. 4 can be written as 4 by 1. Now just cross multiplying, that is what we have done. Okay, so 4 will come here, K2 will go there. I need it in terms of K2. So K2 will go there and 4 will come here. 1 into K1, here it is K1. 4 will come to the denominator. Okay, so you should write till this, and after that one more sentence should be added. That is, when the speed is half, kinetic energy becomes 1/4. Okay, kinetic energy becomes 1/4. Clear? Now, next this should be copied into your book and it should be sent to me. Okay, now we will move to the numericals. Only one question was left there, so we will go to that question. Okay, question number 4. We have completed till question number 3. So we will move to the last question. A 20 kilogram ball. So 20 kilogram means it is mass, isn't it? So mass is 20 kilogram. A 20 kilogram ball is thrown upward with a speed of 4 meters per second. Speed is given as 4 meters per second. First question is, find the potential energy when it reaches the highest point. You are asked to calculate the potential energy. Mass and speed are given. What should we do? What is the equation to calculate potential energy? Potential energy is given by mgh. Mass is given. We know g as 10. Height is not given. Then how can I calculate the potential energy? Without height, how will I calculate? For that, we will be using the example which we learned for law of conservation of energy. So I told you to keep one point in your mind. What was that? Kinetic energy possessed by a body near the Earth's surface will be equal to the potential energy at maximum height, isn't it? Because in the case of free fall, when you are considering the total energy possessed by a body at a greater height, it will be only due to potential. Total energy near the Earth's surface is only due to kinetic. And according to law of conservation of energy, total energy is conserved. That is, total energy possessed by a body will be same at any instant, isn't it? So, what should be your first step? Potential energy. Where is the potential energy? At maximum height, isn't it? So potential energy represented by the letter U. Potential energy at maximum height will be equal to kinetic energy near the surface. Okay, so that's a very, very important thing. Potential energy at maximum height is equal to kinetic energy near the surface. So the ball is thrown from the surface. So it possesses kinetic energy, and that will be same as the potential energy at the maximum point. So this will be equal to half mv square. Half into, how much is the mass? It is 20. Speed is given as 4. Since it is square, you should write it as 4 square. 2 and 20 gets cancelled. Here it is 10. 4 square is 16. Since 1 0 is there, 160. So your answer will be 160 joule. Okay. We are asked to calculate potential energy, but height is not given. So we have used the law of conservation of energy. That is, potential energy at maximum height is equal to kinetic energy near the surface. So half mv square. We have used the equation half mv square. Half into mass is 20. Speed is 4. 4 into 4, 16. 20 and 2 gets cancelled. There it is 10. So 16 into 10, 160. So 160 joule is the answer for the question 1. Now, calculate the maximum height it reaches. So which equation should we use here? U is equal to mgh. From here what will be U? U will be, h. U is equal to mgh. From here h is equal to U by mg. U, already we got the potential energy which is equal to 160. Mass is 20. Acceleration due to gravity, we will take it as 10. Okay. Since they didn't give the value, it is better to take 10. 0 and 0 gets cancelled. 16 and 10. Here it will be 8. Here it will be 10. So how much is 8 by 10? 0.8. So 0.8 meter will be the height. So we have calculated the potential energy for the first question. After that, using that value, potential energy is mgh. We know the value of potential energy, mass and acceleration due to gravity. So we have calculated h using the equation U by mg. U is 160, m is 20, g is 10. So by cancelling, you are getting the answer as 0.8 meter. Okay. So with this, we completed the chapter. Now children, which all things you have to submit in the Google Classroom? I have given you 3 question answers, isn't it? 3 question answers were there, 2 numericals plus the activity. Okay. So please complete this and submit it in the Google Classroom. Okay. Study the topic. I'll be asking questions from this chapter during the Google Meet. And I have asked you to find 2 more things. That is the name given for friction exerted by liquids and gases, plus answer for question number 8 about the marathon runner and the sprinter. Okay. So complete this, study and be ready for your Google Meet. Okay. So thank you children.